People Tech Ramp Group. I've been consulting in automotive on HMI for over a decade now, and I'm here today to give you a sneak peek at what the future holds. It's funny, but at Ramp, we've been bringing highly usable and high quality HMI into the vehicles for some time now. But I will tell you, nothing we've ever done has quite gotten the reaction I get when I tell people we're bringing 3D gaming engine into the vehicle. They are like, whoa, their eyes light up. I've got their full attention now. And that is probably exactly why you're here today. Go ahead and admit it. Haven't we all wondered when these 3D technologies were going to show up in our everyday lives? Well, that's what we're here today to convey. What is 3D really good at? How exactly are we making it happen? And what have we learned along the way? Can you go to the next slide?
We're not seeing slides right now.
Exactly. It seems like the screen sharing hasn't worked so far.
No. Do we can we get that fixed, or is there anything we should do to do that?
Can you just share it, or should I share it myself?
Okay, let me do that. Hold it. Didn't they send you the deck?
Yeah, usually it's the backup version, and in case something doesn't work, we can check if it works now. I think that's probably.
Why don't you go ahead? Why don't you go ahead, and I'll just keep on rolling.
Okay.
The first couple slides are just intro anyway. Okay, I'm on slide 2. I'm on slide 2.
Okay.
Yeah, there we go.
Yeah.
Okay, so before we get going here, let me just tell you a bit about our company. We are a global systems integrator that combines years of experience in HMI and usability design with deep technical expertise that goes right down to the OS, right down to the CAN bus. These skills turn out to be the perfect combination for designing and developing effective, high-quality human-machine interfaces for the automotive vehicles. Next. Our journey in HMI began back in 2010 when we were started consulting with Microsoft's Connected Car Group out of Redmond. We were focused on making HMI that was effective and usable, creating prototypes and user testing them on a simulator. Then we were brought into General Motors to help them revamp their HMI design to dev processes. At GM, we combined our expertise in human factors with our technical depth in embedded systems and implemented a process that allowed them to go from design to a functioning prototype on target hardware within about a week. That really changed the game for them. That allowed them to usability test new concepts and ideas much more rapidly and at a much lower cost than ever before, greatly increasing both their usability and the quality of their interfaces. From there, we just expanded into the cluster displays in the vehicle, into responsive interfaces that automatically fit to various display sizes. As our automotive team grew to over 500 resources, we just continued to take on new and innovative activities within the vehicle HMI. And for the last couple of years, we've been designing and building 3D models that will be coming to vehicles near you soon. And that's what we're going to talk to you here today about. Next. So why 3D? Well, with 3D, we can make driver interactions and information communication even more intuitive than a traditional 2D display. We can use photorealistic renderings and animations that can help the driver more quickly consume the information that we're trying to communicate to them. For example, a 3D model can clearly show the physical dimensions of objects and their size in relation to other objects. So we can use the driver's mental model of their vehicle and the world to help them more quickly understand the location and status of their vehicle components. This makes communicating things like the distance to nearby vehicles much, much more intuitive. Plus, with 3D, more information can be communicated on a single screen with far less navigation between screens needed and fewer instructions and those non-intuitive labels, particularly as you get into localization of those labels. And of course, with less text and instructions on the screen, we have fewer language barriers to deal with, which is just an added bonus of 3D interfaces. And of course, last but not least, the answer to why 3D, because it's cool. One of the great things about working in the automotive industry is we aren't afraid of cool here. In fact, we promote cool all the time because cool sells cars. So with that, 3D has the power to really be something that attracts attention and attracts people's interest. But our job as HMI specialists is not only to keep the cool, but also make it highly usable. So we are going to talk today about the process we use to create these new 3D interfaces of the future. For that, I'm going to bring in Ravi Akella. Ravi leads our automotive practice at RAMP. He has spearheaded many of our ambitious projects over the last decade, and he will be sharing his views on what you'll be seeing in the vehicle in the near future and how those interfaces will be created. Ravi?
Yeah, thank you, Bob. Thank you very much. So hi, all. This is Ravi here. So like at PTG RAM Group, we build the entire HMI, and our HMI development process is roughly categorized into these 4 areas. One is the primary aspect is the research, where we do research on the upcoming usability, upcoming features of what kind of features we're gonna incorporate in the HMI, and we prototype them and we build the designs, and we finally integrate with the software that goes along with the graphics and UI of the onto the target hardware. So we basically follow this 4-step approach, and I'll take you through each of these steps that we follow. And today the focus I'm gonna give is my focus would be restricted to 2D and 3D content and the HMI part. Not, I mean, I'll be talking a little about the software production part, but yeah, mostly I'll be talking, because of time constraint, I'll be talking about the Unreal and the 3D part. So yeah, research. What do we mean by research here? So prior to any 3D work being implemented, what we do is we work closely with the designers, and we get the wireframes and storyboards to showcase the concepts, like how we are going to envision a particular feature, or how we are going to look at a particular feature, and how we want to present it and make it most useful to the end user with maximum usability. That's what we research, and we, our team of designers, work with the various studios, and they come up with these concepts. So that's the first step for bringing or developing the HMI, and then we do a lot of prototyping. We experiment with various concepts, various aspects of 2D and 3D. So specifically, if you see here, like once the base concept is finalized, we actually build the 3D models required for that particular concept, and we define the scene, how that the particular aspect needs to be presented. For example, if you see on the top right, the roll pitch thing, the animation there. So the car model, that's done in Maya with, it's a 3D object, and we define the scene layout, how a basic 3D content, 3D aspect of it is defined, and how the scene should be presented. That is layout is defined, and then we play around with the props, like the background and the foregrounds, and we animate the models, and we do different we play around with different textures and materials, basically making a diffuse map for the lighting, or roughness or normal maps for the detailing, or a specular map for reflection, or ambient or occlusion maps. We play around with these kind of concepts, and we finally do the lighting and post-processing. And if you see the bottom right here, there is another animation that you're seeing where we played around with some shader based animations where a particular shade is being filled around. And this is basically, the materials are being driven by the physics, and, the data is being driven by real-time engines, basically real-time data that we actually get from Canvas. These are some kind of prototypes we develop and try out before we finalize the concepts, and we build them, bake them into the production software. So, in some cases, we also do, the meshes where we rig the 3D content, where if you see the bottom right animation where the shock absorbers are being, that springs, etc., are being moving. So that's basically done by rigging of the 3D meshes, where we use the skeletal mesh. And so like we play around with different concepts in terms of backgrounds and level streaming, etc., and animating the blueprints as well, and mapping different inputs as well. So if you see the top right here, the same car, same visual is being played around with different kinds of backgrounds, different colors. So these are some of the aspects that we play around with. So just to give you an overview, like, if you see this car, the blue color or the red color, that's changing based on the background. So that's one of the prototypes that we did with level shading. So how do we do this? So the first step of this is basically creating a 3D asset. So it all starts with that. So we build the 3D models, and then we optimize them for achieving an appropriate performance. We reduce the mesh count, we play around with the mesh counts, and we fix the UVs and texture maps, and then we rig the models. These are the primary steps for creating the model itself. And then once the model is built, then we take it into Unreal Engine, the real gaming engine, where we do various steps and build the real animation or real 3D 3D deployable application. The first step we follow is the light post processing, where we play around with the shadows and the lighting the elements, probably using the global illumination, or setting up the reflections, or adjusting the exposure and finalizing color grading in the post process, etc. Then materials and instances, we play controlling the appearance of surfaces in the world using shaders and textures, defining different parameters that drive the shaders, and basically calculating how they interact with the lighting, and creating instances for those materials, and tweaking parameters for best realistic visual possible. And then we do the blueprinting, where creating the gameplay elements for various purposes. For example, animating it. Like if I want to show the door open, or the rotation. So those are the things that we play around using the blueprint functionality of the Unreal, and then sequencing them. So like basically cinematics, bringing in the cinematics with specialized multi-track editor animations, like animating the whole object, or moving different objects around the scene. Maybe we call it as transformations. And if anything to do with updating the props or something of that sort. And then we do the profile optimization, where we profile each of the elements, and then content and the code to achieve required performance by collecting and tracking different memory and performance statistics, identify possible sources of slowdowns and probably glitches in the application, and resolve them. So this is what we do during the profile optimization. And the last step is target deployment. So adding native screens on top of the Unreal Engine to communicate with other services outside of Unreal, and integration with custom hardware or the OEM hardware to pass various system and platform related information to Unreal and vice versa. So this is how we bake in, build the applications that run on the target. And so this particular screen shows you like a typical screen where where the 3D content is playing along with the 2D content. So like the entire HMI is not just about 3D, because we also have a lot of 2D content, and that needs to go in as an app. So we have a well-defined process of producing the HMI where we define each of these elements, and we define the layouts. We build the 3D and Unreal. These aspects only give us the assets. The 2D design aspects will give the assets. However, the entire HMI also needs to be developed. So we marry them with the layouts, and then we define the zonings. We define the touch zones, all the strings, the fonts, etc. And then we extract the assets, and we build XMLs or the asset layout definitions basically. Once this step is done, our HMI control logic that we develop in native programming languages, that could be C++, or most of the times Java, or any of the upcoming. We build the HMI control logic. We have multiple tools that generate or that take in these asset screen layouts and generate the code, and they integrate the HMI control models that we define, and then they can be integrated onto the target with integration with the middlewares, etc. And then finally, we do a thorough testing of it, and on various OEM hardware as well as in test benches, and finally we deliver. Even for testing and test automation, we have multiple in-house tools to automate various scenarios and define and understand the functionality and the behaviors. So like that's some sample application that we built. So this is how we produce the HMIs, and we we develop and produce the HMIs. So that's about the HMI process that we have. And let me turn it back to Bob to talk more on our other capabilities and other vision in the area of automotive and HMI. Over to you, Bob.
Thanks. So this work of ours came out of, with 3D, came out of our Automotive Center of the Future. The ACF is where we try out new ideas and see how they work when they really come together with technology. With all the forces today driving changes into the vehicle, things like display sizes, compute power, EV management systems, an explosion of sensors in the vehicle, and of course, autonomous and semi-autonomous features. We felt like we needed a place to bring these things together and to collaboratively work with other vendors and suppliers to see where the rubber meets the road on these ideas, to try them out and to do proof of concepts. In the ACF right now, we're working on some really exciting predictive cloud analytics proof of concepts. Right now, we're including new voice control features in those. And we actually just published a white paper that should be up on our site now on some of the things that we're going after with those HMI analytics scenarios. So if you're interested in more information about the ACF, or you have ideas that you want to explore, please give me or Ravi a call. We're constantly looking for additional partners and additional ideas to explore in the ACF. With that, looks like we've got we're a couple of minutes left for questions. So I think some questions have come in, but and we can get things going. Ravi, one question is, is there anything that you have found that is not really a good fit for 3D?
Ravi, you're on. You're
Yeah,
still
I think I'm
muted.
muted.
Yeah.
Yeah.
And
Yeah. So like, yeah, not good for 3D. Anything to do with linear animations or simple screen-to-screen transitions, which are like pretty basic. And whenever your CPU budget and processing budget and memory budget are tight, definitely I would not watch for 3D. Yeah.
Yeah, and I would add to that that certainly there's things in the vehicle and in our vehicle interface where we already have a very distinct and clear mental model for how it should operate. Things like some of the features, at least on the radio, phoning, or things like that, and those where we already have a good mental model, and there isn't one in the real world that's better. Those are, candidates to stay in 2D to keep things simple. One other question I've got are you worried at all about distracted driving, and is there anything you're doing to minimize that?
Yeah, obviously, 3D definitely, when used right, will minimize driver distraction, because 3D right away gives the context of the information that is being presented. So we definitely use 3D where where we can minimize the driver distraction and improve the way we show the data to the driver, so that we can relate to the data that is being presented and immediately act upon it. So,
Yep, and I would add that that clearly that's one of the things that we really focus on when we're doing any kind of user testing and driver testing. That's one of the key variables we're trying to discern as we try out new things, that the driver really does get it quickly, doesn't have to focus on the interface itself, but can keep their eyes on the road while still consuming the information at a glance. Those are some of the key things we try to tease out. Do we have any other questions?
Yeah,
Chris,
we've
did
got,
any come in?
yes,
We're good?
yeah, we have a few other questions. So one question is, in a few words, why did you choose Unreal? Were you investigating other 3D engines? Why is that one the one to go with?
Ravi, do you want to take that?
so yeah, it's nothing specific to Unreal. So if you see the pipelining that we did, that's pretty much the 3D modeling is done using Maya, and we have capabilities with Unreal as well as Unity and other engines as well. So Unreal is nothing specific, but since a majority of the customers that we work with are inclined towards Unreal, so that's one driving factor. And yeah, definitely we have done several 3D implementations using Unity as well.
But I think I would add that we have seen that some of the Unreal tools are we prefer, and I think that gives Unreal an edge in some ways in that prototyping development stage.
Yeah, and definitely for us it's pretty much easy to scale up, because we I mean, as people take, our interest is not just into automotive and technology, we are also into media. So we have a cross-functional use case there. So like we have in-house capability with Unreal. So that's another availability of resources for us is better in terms of Unreal.
And one final question about processing power. Using 3D models, can you talk about how much more power they consume?
Yeah, the power consumption depends on the the size of the mesh, the size of the objects that we do, and the level of animation that we are trying to do, the transformations that we are applying. So it's relative. So it all depends on the use case that we are doing. Say for example, the ones that you see there are pretty much low power consuming animations, the ones that I showcased, they actually run on target hardware. So with current OEM budgets that we have with respect to the processing and the current trends of the CPUs that are being deployed, it won't be that excessive. That much I can say.
And then just one more quick one on Unreal. What was your biggest challenge in ramping up using it? Strongest business cases for using Unreal as opposed to Unity or some other package, and your ideal team size for Unreal?
Yeah. So like I have team sizes of people anywhere between 2 to 4 members producing solid prototypes, working prototypes, and even we have people 2 to 4 member Unreal experts working and producing content for certain level of production grade projects. So that's how it is. Like my ideal team size for like it all depends on the requirement and the number of animations and the content, the level of content that we are developing, right? So for the prototypes, like we have a very lean R&D team which is very much focused. They churn out the prototypes. So like yeah, my R&D team is pretty lean, and they build prototypes and they're like less than 10 people, I would say.
All right, Bob.
And as we said
Bob?
earlier, we do work with Unity as well, and that's a fine platform also. But we do like some of the Unreal prototyping tools and the tooling that's built in.
Excellent.
Yeah.
All right, Bob.
So
Rob.
like content is one part, and then the HMI control logic, validation, integration with the other pieces of the target software, and validation with the final end product. This is a pretty huge thing actually.
Excellent. All right. Thank you both very much for your time. Thank you very much for the talk and going through all of those questions. That was excellent. Thank you.
Okay, thanks, Chris. Thanks, everyone.
Thank you guys.